I know it's been a long day, a lot of great talks. So I do hope that you guys can take something away from this talk as well. So I want to get right into this. So who am I? I'm a lead consultant at Teraso right now, but I've pretty much done software development throughout my career. Especially with Java. I find the Java ecosystem with Spring and Jakarta EE to be more than enough for all the type of work that I do. Also a great supporter of anything free and open source. So definitely like anything that I can find in the open source domain, I like to play around with that. The most important thing for me, though, is delivering quality software. And just as equally, if not more, I want to do that without burning out my teams. Obviously, like there is a lot of, there's a lot of stereotype about developers and and also about software development work in general. But what I really want myself and my teams to do at the end of the day is like go home happy and the next day like be really excited to come back to work and deliver great software. So that's kind of been something that I really like to focus on. So for those of you who already know about Java, this is a little bit of a refresher for those who don't. So Java has been around for more than 28 years. In the past, it has typically been like new releases would come out every few years, and it will have a big bang of features in each release, but then it would be silent for a long time before the next release. But at the same time, there's a lot of mature open source tooling that has been available for Java since the very early days. We talk about build tools like Maven and Gradle, build servers like Jenkins, and obviously the IDEs. You probably all have touched Eclipse. Also, NetBeans is still around. But what has been happening in the broader software world, say in the last 15 years or so? A lot of new languages are becoming available, especially in the backend space, with Node.js and Go that have kind of become like big over the last few years. Obviously, Rust is joined the group as well, even though it's mostly focused at the system programming level. Also, like from architecture perspective, we are looking at microservices, cloud native, functional programming. All these things have become more prominent over the last few years. Also, like things like distributed version control with Git, or CI/CD, containers, semantic versioning. So these practices are pretty much established at table stakes for the most part right now. And I would also say that from a people side, we have seen the open source community just kind of explode, especially with GitHub becoming this de facto open source source forge. Also, like there's been focus on the developer experience side of things. So yes, the languages are great, the processors are great, but also like how the developers do their work every day is also becoming an important theme for modern software development. So with all that happening, and Java being the slow, conservative way of releasing software, new releases, it kind of didn't feel quite like Java was hanging with the times. And about around Java, around 2017, with Java 9 release, everything changed. So now Java releases every 6 months. So it's on March and September, pretty much every year there's a new release of Java. It has some features. It's not the big bang releases of the past, but it has some new features, some experimental features. And this has allowed it to kind of like catch up to the rest of the newer paradigms that are being propagated by the other languages, right? So, so things that we would never have expected to see in Java are now becoming more and more possible. And if you had attended the talk earlier by Chandra and Rodrigo, they kind of went through some of the new features that Java is bringing to us. But then there's also been some developer quality of life improvements that Java has brought into the picture. So there's a REPL called JShell. Now you can actually run Java files without compiling them. You don't have to do Java C and then Java, then the class file. You don't have to do that anymore. And also the language is being simplified. So that was the talk from earlier today. A lot of cool stuff that they showed, they demoed during that talk. So with all that said, okay, the language is improving, but like overall the developer focus, developer experience focus has been overall to try to reduce the friction and the rote work involved in software development. So what do I mean by that? So, and we actually had a talk like earlier about developer productivity engineering. So he covered some of these aspects of that, right? So there's a lot of like work that goes around just like getting your software built and deployed, and like anything that helps automate or at least reduce the chore involved is always welcome. So from open source world, we have things like ESLint, Husky, that help us with like doing some of the things that we would have to manually do. And then even some of the language ecosystems like Go and Node are providing some tools that are purely quality of life improvements. Like Go FMT is like a formatter that Go provides, NPM obviously from Node. But what about Java? So we talked about Java having new features, new language features, but what about the developer experience focused tools? So we obviously have Maven and Gradle, which have a plethora of plugins that help make our lives easier. We can also use the generic tools, the non-language specific tools like Husky in our development process. But what about core Java itself? Unfortunately, there is progress being made as we attributed to, but the real kind of solutions or the real world solutions are actually coming from the open source community. Some of it is innovation, some of it is imitation, meaning like we are looking at what the other ecosystems are doing and we are just like adopting those. So this talk is about like 4 of those tools that are Java aligned but not provided by the core Java development team. And we are going to try to look at this from an angle of if you're a completely new team that is building a Java application, what are the different stages you go through and what are the tools that are available for that. All right, so if you're a beginner in Java, you probably remember back to the days like, oh, you first have to set up a JDK, and you're like, which JDK do I choose? How do I install it on my machine? And then you need a way, obviously, to write and edit the code. We use IDEs for that. But what about building and running the programs? If you're a complete beginner, it can be confusing and like a lot of friction there. Obviously, we talked about the Java language syntax itself, which can be a little bit too much and when you're trying to learn the language. And this is where this tool called JBang comes into the picture. So it was originally built to kind of build and run Java or JShell scripts and jar packages. So basically, like to take away all the ceremony around what it takes to build that Java source and to just be able to just execute it like a Python program or a Java or a Node program. That was what the tool was aimed at doing. But it slowly started adding more features. So one of the first things it does when you try to install it is it tries to see if you have Java in your system. And if you don't, it will automatically download a JDK and install it for you. Similarly, when you try to edit the code, it will check to see if you have, it will, actually it doesn't check, it will ask you, do you have a code, do you have an IDE to do it? And if you don't, it can download VS Code with Java support enabled, and you can use that. So this kind of takes care of a couple of things that beginners run into, which is not having the JDK or not knowing what tool to use to edit the code. And how does this work? So if you had a hello world.java source file sitting in your directory, you can just do JBang hello world.java, and it would just run. It would compile it, and it would just run it. And if you build the source file with JBang, then you can even execute it directly as an, just as an executable. It has executable permissions on it right away, and you can just execute it. Furthermore, like what JBang does is it adds powerful scripting features to Java. So for example, like you can pass in command line arguments or system properties directly to your source file. So you can just say JBang, something.java, and then pass in a bunch of parameters, and it will just like, pass those into the code and like process it. So in this way, it kind of exceeds what we can do with the JShell REPL, right? And then another really cool feature, which is what really turned me on to JBang, is like you can use dependencies in your source code. So you can just like put this line here which says / deps, and put the Maven coordinates of the dependency that you want, and then just import and use it just as regular. No need for Maven, no need for Gradle. You can just like, it will put it in your class path and make it available to your code. So in this way, like it surpasses the Java 11 ability to basically like run the source files directly, because it also allows you to import dependencies. And finally, we talked about being able to run jars. So yeah, so if you have a jar sitting in your local, or you downloaded a jar, you can just say JBang hello world.jar, and it will execute it. But what is even more cool, again, is you can actually specify the Maven coordinates to a jar in Maven Central or wherever you have your artifacts, your packages, and then it can actually download it, resolve it, and execute it on your local. And if you need to specify a main method, there is a main --main option to specify the main. So what does this do? So the really cool thing here now is that you can actually play around with any libraries or APIs that are available on Maven Central or anywhere else, and like just like play around with them without having to go through like all the steps of like writing code and like creating a Maven pom.xml and all that stuff. Well, that's not all. So another cool feature is you can actually run Java source files that are hosted on URLs, right? So you're primarily talking about things like GitHub, GitHub Gist, GitLab, Bitbucket. So if you have a source file there, and you can actually just say JBang URL to that source file. And what JBang does is it will parse through the HTML and just pull just the Java source out of it and execute it on your machine. Obviously, you don't want to run untrusted code from the internet. So it won't, like at the first time you try it, it won't allow you to execute it. But once you mark the code as, or once you mark the URL as being trusted, then it will allow you to run it either once or like for several other times, depending on which option you choose. So this is again really cool, because if you see, you want to share code snippets with your coworkers or like with anybody else, like if they have JBang, then you just need to provide them the URL and they can just do it without any setup. Another feature that I really like is that you can install the source files as apps on your system. So basically, JBang will like add it to your path and like make it available. So if any shell that you open, you can basically just type the name of the file. Like in this case, like you say, okay, install hello world.java, and now you open any shell or any terminal, hello world is available to run. And then you can list all the JBang apps that are available, and you can uninstall them. So what this helps with really is automation. So you can like, if you combine the 3 previous features that we talked about, like you can host stuff at URLs, and like you can, like install them locally as jars. You can also like install them as apps on your system. Like all this helps with just being able to automate your workflows. If you're setting up CI/CD, you can use JBang to basically like provide the build tools that you need or build scripts you need. And you can write it all in Java. You don't need to do Python. You don't need to do Bash. You can just write stuff in Java and like use it everywhere. All you need is to be able to install JBang on your target machine. So just a couple of technical things. So JBang, there is some IDE support from a handful of IDEs. The way it works is JBang inserts this line, which you see the / user something, and basically the / just like is a comment, and so ignored by the IDEs. Then you can edit the Java code. Whereas if you use the shebang notation, which is what Java 10 supports, then the IDEs will complain and they won't then you cannot edit the code or do anything with IDEs. So this is a trick that the JBang creator found from Go. Also, we have Maven and Gradle plugins, so you can actually like write invoke JBang scripts from within Maven and Gradle. All right, so again, like just a quick, covered some of this already, but the idea is that this provides a way to not just create and run scripts, but you can also share it. And you can also share it with non-technical people. So if you write some code in Java that you want to share with somebody who's not a technical person, like as long as they can get JBang on their system, they can run it. And also it's a cool way for students and educators, like if you're trying to run a workshop or you're trying to teach some high school students about Java, like you can like get them started very quickly. So that's with the initial like learning Java, getting started with Java. But once you start like working on multiple projects, right? So one of the common things you run into is like, hey, this program or this application uses Java 8. This application has features that are Java 17. This application has Java 11. And so then you can run into this problem, like you need, how do I install all these versions? How do I switch between them when I'm executing different projects? Or when you're basically even editing different projects, or when you're just working with different projects, how do you manage all that? And the Python and Ruby and Node, they have solved the problem with things like VNV and NVM. So why doesn't Java have an option? Actually, we do, and that is called SDKMAN. So SDKMAN provides the CLI, which is very similar. It's inspired by all these other tools that we talked about, including apt and pip, and it just is a very easy and intuitive way to manage different SDKs on your machine. So how it works, like for example, after you have installed it, if you just say SDK list Java, it will show you all the vendors that it supports, and there are a ton of them. Pratik was here earlier talking about Azul systems, but so that they also provide the JDK through SDKMAN. But there are also the more common ones like Eclipse, Oracle, Amazon. Like all those JDKs are available from SDK. And then similarly, like even within each vendor, they provide multiple versions of Java, like 8 through 23 and beyond. So you can specify like install Java 17.0.13, and this TM is for Temurin, which is the Eclipse JDK. So you can just install very specific versions of Java and for specific vendors. And you can do this many times, right? You can install as many as you want as long as it's available on SDKMAN. I have noticed that sometimes they deprecate older versions, so you may not always find Java 8 everywhere, but like at least with the newer versions, you'll always find it. And you can install it and like manage it all through SDK. And you can set a default. So if you have several JDKs, then you always want to have your shells open with in a specific version of Java, then like set the default. Say SDK default Java and then 23, and then everything will be Java 23. But now if you wanted to switch back to a different version of Java for your current shell, then you just say SDK use Java 17 in this case, and it will switch back to version 17. But if you open a new shell, it will go back to 23. So clearly, like this is a very simple and easy way to manage the different JDKs. You can also uninstall JDKs if you don't need them anymore. But then one of the challenges is you have to remember, okay, this project uses this Java, this version, and like it can become like painful after a while. So how can we like pin a particular version of Java to a particular project, and or a particular version of JDK to a particular project? And that's where we use this env feature. So if you set the Java using SDK use Java version, and then you say SDK env init, it will create this file called SDKMAN.rc, and that pins the version of Java that goes with that project. And then you can just check it into your Git repo. So the next time anyone downloads, they will have SDKMAN.rc, and all they have to do is SDK env install. If they have SDKMAN on their system, it will automatically initialize and install that specific version of Java. But there's more than just Java JDK available with SDKMAN, right? So we also have a plethora of other SDKs available. So like Scala, Kotlin, Groovy, all the JVM languages. I'm even sure Clojure is there as well. You can use, if you want to install Gradle or Maven, like you can install it through SDK. And similarly, like if you wanted Spring Boot, Grails, Vertex, Spark, any of the frameworks, they are available through SDK. And then finally, like even the other tools we are talking about in this presentation, JBang, JReleaser, they're all available through SDKMAN. So it can be your one source to manage everything Java on your laptop. Like all you need is SDKMAN, and it's a very simple API. All right. I'm kind of going through it a little quickly because I'm trying to get through all this stuff, but please feel free to catch up with me later if you have more questions. So once you get into the kind of active flow of developing an application, there's a lot of other things other than just writing the code, right? So there's like, your team has a Git workflow that you have to maintain or have to adhere to. There's all kinds of CI/CD pipelines that have their own requirements about how you check in code and where different things get built and deployed. There's also this whole like versioning aspect when it especially comes to like releasing code into your production environments. And there's the whole semantic versioning concept, major, minor, patch, that's kind of become the de facto standard. And obviously that doesn't work with the Maven conventions that were established a long time ago. So how do you manage all that? And it can become really painful if you're doing it manually. And that's where this plugin called jgitver comes into play. So what jgitver is it basically goes through your Git history and computes the version, semantic version, on like every time you basically run jgitver. So it doesn't have to rely on any manual intervention. It can compute, and because of that, your project history is very clean. Especially if you have worked with this Maven release in your pipelines and you know how much junk commits it creates. And then when you try to merge it back into your master, it creates another set of issues. So all that is gone. Like you can have complete clean CI if you use jgitver. The main concept that jgitver uses is basically like annotated tags and lightweight tags. So if you use a git annotated tag, right, so git tag -a 1.0, that is considered a major version. So you annotate, so once you are ready to release a major version, that's how you would do it. You would put an annotated tag, and then jgitver knows that you're now bumping up to the next major version. Similarly, if you use a lightweight tag, like in this case, just say git tag 1.1, it knows that now you are basically like in a minor version, which is a non-breaking change. So just with these two actions, you can basically like control the versioning, and then jgitver will always consistently calculate the correct version based on the Git history. So again, like there is a Maven extension. You just need to add it to your extensions.xml, and if whenever you want to compute the version, this step Maven validate will basically do the computation. Similarly, Gradle has a plugin, and if you run Gradle version, again this will like compute based on the Git history. Now jgitver supports like 3 different modes, or like basically it has this thing called a Maven mode, a Gradle mode, and a custom mode. So basically those are conventions about the Maven convention, and then the Gradle convention about release versioning. So you can indicate what strategy you want to use. Whereas if you use the Maven plugin, it will automatically default to the Maven mode. And this basically shows you like how it works, and we just kind of covered that. But the main thing I want to point out in this picture is if you create a branch out of the master, it will actually add the branch name into the version. And this is really helpful, because if you have one person in your team working away on on a bug somewhere, and you start working on a different bug, but you are just, both of you are branching off of this of the minor version, then when you will both basically end up calculating the same version. When you try to merge back things in, it becomes a mess. So by adding the branch name, it will basically make sure there are no conflicts between the version numbers. So I thought that was a very clever way of handling that scenario. Similarly, it does this very similar thing with Gradle, obviously without the snapshot or the release stuff. All right, so we have 2 more minutes. I'm going to run through the last thing here. So the last thing is, once you have gone through all this, like you set up your machine, you set up your JDKs, you've been developing your code, and you finally want to release it, especially if you're doing something like a library or a framework or something like that, then there's a bunch of chores when it comes to rolling stuff out, right? You have to create a release, you have to create the distribution artifacts, then you may want to announce it in different mediums. So there's a lot of like chores around that. And that is where JReleaser helps you. So JReleaser basically automates all of that, right? And it's inspired by this tool called JReleaser. But basically what it does, it creates Git releases, it publishes your artifacts to multiple package managers, and it also announces releases. So what does that all look like? So this is basically what it looks like. So your build tools will generate the artifacts for your release, and then JReleaser uses that to build the release for the Git releases, like it can do GitHub, GitLab, etc. It can package and make it available to your different package managers, and it can also announce through different media. So the integrations, they support a lot more, but an example here is GitHub, GitLab, Codeberg. It can create those releases. So if you go to GitHub repos, you see those releases. Like it can build that. Similarly, it can publish to AppImage, Flatpak, Snap, even to Docker. It can basically publish those to those package managers. And similarly, like you can announce to Slack, through Slack, through Teams, LinkedIn, like whatever medium. If you want to announce the release of your software, then you can do it. And all this is done by just configuration, right? So if you use the CLI, there's a JReleaser.yaml file or tomls, JSON, whatever format you want. Or if you use the plugins for Maven, you can configure it in the POM or Gradle in the build.gradle. And ultimately, you can also use this in your CI/CD platforms. It supports things like GitHub Actions, Jenkins, CircleCI, etc. So to wrap up, there are a lot of open source tools available in the Java for Java developer experience. So please look into these, try to use them. They're all very easy to use. Contribute back where possible, and always like be learning from other ecosystems. Like we need to take the good things from the other languages, bring it back into Java, so Java can always stay in touch with the rest of the world, right? These were the tools we talked about. These are links to their pages, and this is a contact info for me if you want to talk to me, catch up with me later. But that's it.